This is SpaceTime Series 24, Episode 66. Coming up on SpaceTime, a new study of the distant Oort cloud, heavy metals found in comets for the first time, and astronomers studying mysterious objects known as ultraluminous X-ray sources detect unusual flaring activity. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have undertaken a new analysis of the Oort cloud, a sphere containing some 100 billion comets and chunks of icy debris in interstellar space, which are gravitationally bound to the Sun. The new study, reported in the journal Astronomy and Astrophysics and on the pre-press physics website archive.org, looks at the first 100 million years of the history of the Oort cloud in its entirety. The cloud was first postulated back in 1950 by the Dutch astronomer Jan Henrik Oort in order to explain why there continues to be so many new comets with elongated orbits in our solar system. The Oort cloud is thought to extend out more than 3,000 astronomical units from the Sun, an astronomical unit being 150 million kilometres or 8.3 light minutes, the average distance between the Earth and the Sun. The Oort cloud is different from the Kuiper belt, a ring of frozen worlds, comets and icy debris circling the Sun beyond the orbit of Neptune between 20 and 50 astronomical units out. The Kuiper belt was formed out of the builder's rubble left over from the formation of the solar system 4.6 billion years ago. But the origins of the Oort cloud have remained somewhat more mysterious. The new computer simulations by astronomer Simon Portega-Svart and colleagues from the University of Leiden suggest that the Oort cloud is actually a mixture of remnant debris from the protoplanetary disk of gas and dust which form the solar system and interstellar material from other star systems, captured when the newborn Sun was emerging from its stellar nursery. Exactly how the Oort cloud formed has remained a mystery because the series of events which took place to build it involve complicated computer analyses which are difficult to reproduce. The authors say some processes lasted only a few years and took place at relatively short distances, comparable with the distance between the Earth and the Sun, while other processes lasted billions of years and took place over light years, comparable with distances between stars. Svart says if you want to calculate the whole sequence in a computer, you'll irrevocably run aground. That's why until now, only separate events have been simulated. The Leiden University research team started from these separate events, but they were then able to connect these events with each other, using the end result of one calculation as the starting point for the next. In this way, they were able to map out the entire genesis of the Oort cloud. This is SpaceTime. Still to come, heavy metals found in comets for the first time, and astronomers studying mysterious objects known as ultraluminous X-ray sources detect unusual flaring activity. All that and more still to come on SpaceTime. Two separate studies have found heavy metals in the atmospheres of comets. One study detected iron and nickel in the atmospheres of solar system-based comets, even those far from the Sun. Meanwhile, a separate study found nickel vapor in the atmosphere of the icy interstellar comet Borisov. Both studies are reported in the journal Nature. It's the first time heavy metals, usually associated with hot environments, has been found in the cold atmospheres of distant comets. Scientists from the University of Liège detected iron and nickel atoms in the atmosphere of some 20 comets they've been observing for the past 2 decades, even those far from the Sun in the cold environment of deep space. Now, astronomers have always known that heavy metals like nickel and iron exist in comets' dusty and rocky interiors. But because solid metals don't usually sublimate at low temperatures, they didn't expect to find them in the atmosphere of cold comets that have travelled far from the Sun. Yet nickel and iron vapor was observed in the atmosphere of comets more than 480 million kilometres from the Sun. That's some 3 times more than the Earth-Sun distance. Interestingly also, the Belgian team found iron and nickel in comets' atmospheres in approximately equal amounts. Material in our solar system, for example that found in the Sun and in meteorites, usually contains about 10 times more iron than nickel. That means these new results have serious implications for astronomy's understanding of the early solar system, although the team is still trying to decode exactly what those implications are. Comets are thought to have formed around 4.6 billion years ago when the solar system itself was forming and haven't changed much since that time. They therefore provide a really good archaeological record of the early history of the solar system. Meanwhile, astronomers from the Jagiellonian University in Poland have detected gaseous nickel in the atmosphere of the interstellar comet Borisov, the first identified alien comet to pass through our solar system. Borisov was observed when it was some 300 million kilometres from the Sun, again about twice the Earth-Sun distance. Both teams' discoveries were made using the European Southern Observatory's Very Large Telescope in Chile. To find out more about what these discoveries could mean, Andrew Dunkley speaking with astronomer Professor Fred Watson.
Now, Fred, let's start with heavy metals in comet vapour. This has just been discovered, and I'm guessing there's a paper or at least some form of study that's come up with this interesting discovery, this interesting find.
Indeed, yeah. There is a paper and lots of press about it as well, because it's a really interesting result. And I should tell you that these studies use the telescopes of the European Southern Observatory down there in Chile, which are pretty well the best equipped large telescopes in the Southern Hemisphere. There are a few other ones down there which are pretty damn good as well. But the 4 telescopes of the Very Large Telescope, they're cracking good. And so they were used to make these observations. And what's interesting about this is by heavy metals, actually we should perhaps just define that for a minute, Andrew, because astronomers
Good idea.
have got a very funny view of what constitutes a metal. And a metal in astronomy is anything other than hydrogen and helium. So oxygen's a metal, calcium's a metal.
Oh, right.
Yeah. It's always been like that, I guess, probably since the start of astronomical spectroscopy, the idea of breaking up the light from stars and finding out what signatures of elements you can get in there. But yeah, metals are anything heavier than hydrogen or helium. So when you talk about heavy metals, you're really talking about what you and I would call metals in normal life, and in particular iron and nickel. And iron is the commonest metal in the universe, in fact one of the commonest elements, and it's because it's a byproduct of the nuclear processes that go on inside stars when they're in their normal adult life. So iron is being created towards the end of the life of the star, actually. Anyway, the bottom line is iron is common, nickel is common. Now, there is an interesting little factoid about this, though, and that is that we find, for example, in the core of the Earth, it's an iron-nickel core, and the iron usually outweighs the nickel when you find it in nature, like metallic asteroids or the core of a planet. It's usually 10 times more iron than nickel, which is understandable because iron's more readily produced inside stars. But in this story, we find that in these comets, you've got more or less equal proportions, and that is unexpected, that there are equal proportions of iron and nickel in the comets. Now, we've known for a long time that comets must have this sort of stuff in their material. Remember, comets are icy bodies with lots of dust embedded in the ice, and that dust includes heavy metals, and the temperatures of these things are typically colder than minus 100 degrees Celsius, so they're very, very cold, and the metals normally remain very much as grains of dust, basically, not anything that's vapor. But that's the surprise with these observations, and it comes from groups in Poland and Melbourne, I think, Poland and Belgium, I think, are the main centres where the astronomers who've worked on this come from. There are 2 studies, actually. In fact, let me get it right. The first study is the solar system comets, and that's the Belgian study. The second one is our old friend Comet Borisov, which has been looked at by a group from Poland. Boris, that's the one, yeah. Both of them have found this unexpected result that the metals turn up in the vapour of the comet, the stuff that's ejected from the comet when it gets near the sun, so that material vapourises. Now, normally, these elements, they vaporise at very high temperatures, 700 degrees Celsius or thereabouts. And we're talking here about minus 100. So what's going on? I should just clarify there that when I say vaporize, I mean they sublimate. And sublimation is the process when a solid turns directly to a gas, which happens a lot in astronomy because it's what elements do in a vacuum, basically. It goes straight from solid to gas. It's why on the surface of Mars, which is not a vacuum but not quite, ice doesn't turn into water. It just turns straight into water vapor. So that's the process, sublimation. But the mystery, why is it that at these ultra low temperatures, these metals are turning into vapors? And I think, as I understand the research, I can quote actually from the paper, and you'll see the problem. The paper says unbound nickel atoms seem to originate from the photodissociation of short-lived nickel-containing molecule that sublimates at low temperatures or is otherwise released with major volatile compounds. Did you get all that, Andrew? Because that's the answer.
Yes, I did.
Yeah.
Okay.
What it means is that the key word there is photodissociation. It's the radiation of the sun hitting these things, and it's a nickel-containing molecule. And basically, the radiation from the sun shoots out the nickel atoms. And the same is probably true with the iron, I think. That's the story, that it's all about the sun's radiation acting directly on these atoms.
If you'd asked me, Fred, to guess before you told me the answer, I would have said, I'm going to imagine it's something to do with the sun hitting the comet.
Yeah, you see,
that's what I would have said.
You should be an astronomer, Andrew, because you've been mixed up with it for too long. But yeah, absolutely right.
I'll be a journalist. We don't have to think much.
I think that's not quite true, but never mind.
Sorry.
It's, I don't think you think at all, do you? No, I never said that. Journalists, I think, have to think an awful lot. And a lot of them, these forensic journalists and investigative journalists, they're doing a fantastic job uncovering all kinds of miscreants.
It's tough work, though.
Yeah, it would be.
Don't make many friends.
No, I bet you don't. It's a good job you've got me, isn't it, really?
Yes.
Anyway, going back to that, you were right on the money. It's to do with the sun's radiation. To be honest, I would have guessed something similar, but I think I would have got it wrong. I think you got it right. I would have thought, it's the subatomic particles in the solar wind that do this. And it doesn't look as though that's what it is. It's actually the radiation, the light radiation from the sun. So there you go.
Well, when I say I think it's got something to do with the sun, that's a pretty broad answer.
Yes.
That could mean anything. So that's a journalist at work.
Yeah, that's right. Make it broad. So I guess the nice twist in this is the Polish work that has looked at Comet Borisov, the first interstellar comet that we've ever observed, and found that it's got very, very similar properties to solar system comets. And in fact, some work revealed that it seems to be like a solar system comet in every way, except it's never been near a star. So it's a pristine sample of the raw material of stars and planets. Really interesting that it's an icy remnant of the gas and dust cloud that solar system, wherever it was formed in. And this work, kind of underlines that.
Yeah. I'm not surprised the Polish looked at Borisov. It's a very Eastern Bloc name.
It's an Eastern Bloc name, that's right.
I wonder if that's why they chose to look at it. Well, just the opportunity presented itself, I imagine. And I don't suppose can we ever figure out exactly where it came from?
Borisov, no, it's kind of a bit of a mystery, really. You can see what direction it came from, but you don't know how long it's been travelling in that direction.
No.
And like our old friend Oumuamua, which came from the direction of the bright star Vega. But when Oumuamua was where Vega is, Vega wasn't there. It was somewhere else because Vega's moving as well. The comets are moving and Vega is. Anyway, so we'll probably never know.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come. Astronomers studying a mysterious object known as an ultraluminous X-ray source have detected unusual flaring activity. And SpaceX has successfully launched a new supply mission to the International Space Station. All that and more still to come on Space Time. Astronomers studying a mysterious object known as an ultraluminous X-ray source have detected unusual flaring activity. First discovered back in the 1980s by the Einstein Observatory, ultraluminous X-ray sources are point sources of intense X-ray energy. less luminous than the active galactic nuclei of feeding supermassive black holes, but consistently more luminous than any known stellar processes. Although the Milky Way galaxy has no known ultraluminous X-ray sources, most galaxies have at least one, and some have several. Astronomers use the XMM Newton, NuSTAR, Chandra and Swift space telescopes to observe an ultraluminous X-ray source known as X7. It's one of two ultraluminous X-ray sources, the other designated X10, located in the intermediate spiral galaxy NGC 4559, some 29 million light-years away in the constellation Coma Berenices. A report on the pre-press physics website archive.org says X7's long-term X-ray light curve shows flux variations by up to a factor of 6 over just a few hours. Such activity wasn't seen in earlier observations of X7 and only manifests when the source is at its highest observed luminosities. In fact, during the peak of the flares, the luminosity was at a factor 3 higher than pre-flare luminosity, indicating the maximum variability of the source can span almost an order of magnitude. It's thought that many ultraluminous X-ray sources are in fact far background quasars, powerful jets produced by feeding supermassive black holes. Another possibility is that they could be feeding intermediate mass black holes, while a third possibility is that they're unusually bright supernova remnants, at least on short timescales. The mystery continues. This is Space Time. Still to come, SpaceX successfully launches a new supply mission to the International Space Station, and later in the science report, secondhand smoke exposure as a child linked to a higher risk of attention deficit hyperactivity disorder. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. Now, this is the service that our team at Bytes.com use to buy and manage our domain names, and we're really happy with the service, support and value we're getting. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. And you can find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with well over 10 million domains, you'll know you're in safe hands when it comes to turning your website idea into reality. And they've got some excellent tools to help you find the right name, like the handy search engine. All you do is type in your desired name, cross your fingers, and press search. And if what you want's already gone, and it does happen sometimes, they'll come up with some great alternative ideas. And if you're looking for some new inspiration, try the new website domain name finder, Beast Mode. It'll help you discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive, and they're easy to use with excellent custom support if you need it. All in all, it's a great experience all round if you're looking to pick up a domain name or two. So, why not check them out and help support our show at the same time? Just visit spacetimewithstuartgary.com/namecheap. That's spacetimewithstuartgary.com/namecheap, and Namecheap is one word. You'll find the URL details in the show notes and on our website. Just visit the support page. That's spacetimewithstuartgary.com/namecheap. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
SpaceX has successfully launched a new supply mission to the International Space Station. On board the Dragon 2 cargo capsule were some 3,300 kilograms of supplies, equipment and laboratory experiments for the orbiting outpost. The CRS-22 mission was flown aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center at the Cape Canaveral Space Force Station in Florida.
Today's cargo mission, known as Commercial Resupply Services Mission 22, is scheduled to launch at 1:29 p.m. Eastern Time. It will be the second resupply mission to the space station on the upgraded Cargo Dragon spacecraft.
It's the fifth Dragon flight to the International Space Station since May 2020, with many more planned for the upcoming year. And as you mentioned, this will be the second cargo resupply mission for our upgraded Dragon. This cargo vehicle will be joining the Crew 2 vehicle on orbit, making it just the third time that we've had two Dragons docked at the space station. A brand new Falcon 9 booster. This is actually the first new booster that we're using this year, and the vehicle stands 229 feet tall, or slightly taller than a 21-story building. Now, Falcon 9 is a reusable two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of both people and payloads into Earth orbit and beyond. This Falcon 9 rolled out to the pad and went vertical on Tuesday, June 1st around 3 p.m. Eastern Time. And actually, just before the program started at around T-minus 35 minutes, we began loading propellants onto Falcon 9. Falcon 9 uses two propellants. The first of those is a fuel, a refined form of kerosene known as RP1 or Rocket Propellant 1. And for our oxidizer, we use super chilled liquid oxygen, referred to as LOX. We chill the LOX well below the boiling point, which helps increase its density so we can load more of it into the first and second stages. Now, to start the engines, we also need an ignition source. For that, Falcon 9 uses a chemical igniter called TTAB. You'll see a characteristic green spark at around the T-minus 0 mark right before the rocket takes off. Now, the bottom two-thirds of the vehicle is what we refer to as the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere to space, and then it'll separate from the rest of the rocket. Today, we will be attempting to recover this first stage on our drone ship named Of Course I Still Love You. That's stationed out in the Atlantic Ocean. And if you've been keeping count at home, if we successfully land the Falcon 9 today, it'll mark our 86th successful landing of an orbital-class rocket. Now, on top of the first stage, we have Falcon 9's second stage. It has a single Merlin vacuum, or MVAC, engine that ignites after the first stage separates. The second stage is ultimately what will carry Dragon into its intended orbit, allowing Dragon to then separate, and then eventually for it to continue with its rendezvous to the International Space Station. Now, finally, at the very top of the rocket is the Dragon spacecraft. Dragon was designed from the beginning to be reused. This new version of Dragon was designed for up to 5 flights, while the previous version could only support 3. Just like today's Falcon 9, we're flying a brand new Dragon spacecraft, which we'll hope to fly again in the future. Now, today is a cargo mission, and we are delivering nearly 7,000 pounds of cargo to the International Space Station. That includes critical material to support dozens of science and research investigations that'll happen on board the orbiting laboratory. To this day, Dragon remains the only spacecraft currently flying that's capable of transporting significant amounts of cargo to and from planet Earth.
One other really cool thing about this first stage booster, if SpaceX successfully recovers it and refurbishes it, this is the same booster slated to launch the next 4 astronauts to the International Space Station in October. Those will be NASA astronauts Raja Chowdhury, Thomas Marshburn, Kayla Barron, and European Space Agency astronaut Matthias Maurer. So NASA's Commercial Crew Program folks watching this mission closely with a particular interest in that first stage booster.
Falcon 9's in startup.
Dragon is in countdown.
LD, go for launch.
Launch director pulled
Stage
go
2,
for
press
launch.
for flight.
So with that, all systems are currently go.
Stage 1, press for flight. Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And liftoff of the 22nd SpaceX cargo resupply mission, bringing new solar arrays to the International Space Station.
Stage 1, propulsion is nominal.
We're coming up on the next major milestone. That's the point of maximum aerodynamic pressure. That's when the stresses on the vehicle will be the highest.
Active Q.
So in preparation for maximum aerodynamic pressure, we throttled down those Merlin 1D engines. Now that we're through that point, we'll throttle back up and continue on to the next of our sequence of events. We have several happening in rapid succession. That'll be main engine cutoff, followed by a stage separation. Then we'll have a first stage flip maneuver, second engine start, number 1, and then a boost back burn on the first stage. Now, main engine cutoff, or MECO, that's where all 9 of the Merlin 1D engines on the first stage will shut down. That's followed shortly after by stage separation, when both the first and second stages will separate. From there, the first stage will flip to prepare itself for entry. A few seconds later, the Merlin vacuum engine on the second stage will ignite to boost the Dragon into a low Earth orbit. That's called SES-1. And then finally, on the first stage, we'll have boost back burn start to slow down the first stage in preparation for re-entry.
And Miko.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
So successful Merlin vacuum engine startup. First stage has begun its boost back burn. That burn expected to last about 30 or so seconds. The second stage will continue to burn here for several minutes until about the T+8 minute mark.
Stage 1 boost back shutdown.
This is SpaceX's 17th launch of the year. Now, the rocket has to do more than just go up. It has to go sideways really fast. At liftoff, gravity is pulling straight down on the rocket, but as we ascend, we tilt the engines. That's called gimbaling, and that begins to turn the rocket horizontally. We're still going up, but we're also heading horizontally away from the launch pad. That maneuver is called a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or about 17,500 miles an hour, to avoid being pulled back down to Earth and to get into orbit. So that's what the second stage is doing right now. Now, the first stage, in order to make its way back to our drone ship, named, of course, I Still Love You, it has 2 more burns to do. First is an entry burn. It'll ignite 3 of its Merlin 1 engines. That'll help to slow it down as it re-enters the Earth's atmosphere. And then the next activity will happen much closer to the drone ship. That is the landing burn. Will ignite just the single center Merlin engine to bring the vehicle's speed rapidly down to 0. The grid fins that are extended, we use those for atmospheric control. They help steer the Falcon 9 to make sure we make our way back to that drone ship as we get into the thicker parts of the Earth's atmosphere. Periodic bursts of a white gas, that's our attitude control system, giving us little corrections to our attitude. The next major event coming up here for the first stage is entry burn. 3 of the Merlin 1D engines will ignite. Second stage burn continuing to look nominal. Second stage has a little ways to go. It won't be done with this burn until about the T+8 minute mark.
Stage 1 entry burn startup.
Stage 1 FTS is safe. Trajectory nominal.
Stage 1 entry burn shutdown.
So from here, the grid fins will continue to take the first stage towards our drone ship stationed out in the Atlantic Ocean. At this point, T+6.5 minutes into flight, second stage is making its way to the initial orbit to drop off the Cargo Dragon spacecraft of the first stage during re-entry. Once we get closer to the drone ship, we will deploy our 4 symmetric landing legs around the base of the first stage for hopefully a nice soft touchdown on that drone ship.
Stage 1 landing leg deploy.
Picture perfect landing of that Falcon 9 for the first stage. First landing for this first stage. 86 successful recovery overall for SpaceX. Fantastic. Now, coming up shortly, second stage is not done. It will be coming up on second engine cutoff.
Expected loss of signal.
Shutdown of the second stage engine. From here, we'll be looking at telemetry, make sure we are in the intended orbit.
Nominal orbit insertion.
Fantastic. So with that, the second stage has just one major task left. It is commanding separation of the Dragon spacecraft. Until separation, the second stage will be making some small adjustments during this coast prior to Dragon separation.
Included in the manifest were 128 tiny baby bobtail squid and some 20,000 microscopic tardigrades, often known as water bears. Tardigrades can survive in extreme environments on Earth and even desiccate in the vacuum of space. By identifying the genes behind their adaptability, scientists hope to better understand the stresses on the human body during long-duration space flights. As for the bobtail squid, well, they're part of a study investigating the relationship between beneficial bacteria and their animal hosts. See, the squid are in a symbiotic relationship with the microbes. Other experiments on board Dragon will examine oral hygiene in space, the increased susceptibility of astronauts to develop kidney stones during spaceflight, as well as experiments growing chili pepper plants and cotton seedlings in microgravity. Also included were fresh lemons, onions, avocados and cherry tomatoes for the station's 7 crew members, and the first of 3 sets of new high-tech solar panels designed to bolster the space station's power grid. Astronauts will conduct 2 spacewalks later this month to help install the 2 roll-out solar panels, which will be placed alongside the existing solar arrays, which have now been in continuous use for more than 20 years. The added power will be useful now that the station's standard crew complement has increased to 7 people and that more space tourists are likely to be flying up there in the next few years. This is SpaceTime. And time now to take yet another brief look at some of the other stories making news in science this week with a science report. A new study has linked secondhand smoke exposure as a child with a higher risk of attention deficit hyperactivity disorder symptoms. The findings, reported in the Journal of the American Medical Association, looked at the exposure to smoke of 45,562 children with ADHD. The authors found that 10% of kids regularly exposed to secondhand smoke had ADHD symptoms, compared to just over 1 in 20 children who had rarely been exposed and 1 in 30 who had never been exposed to secondhand smoke. A new study has concluded that people who get their news mostly through social media are less likely to go for the COVID-19 vaccine. A report in the journal PLOS ONE looked at the social media habits and opinions on the COVID-19 vaccine of 2,650 US residents. They found that 2 in 5 participants were likely to have the vaccine, just under half were somewhat hesitant, and just over 1 in 8 were unlikely to take the vaccine. The study found that those less likely to get the vaccine use social media as their sole or primary source of news and information, while traditional news sources like local and national TV and radio and newspapers were associated with a higher willingness to be vaccinated. Meanwhile, a new survey warns that 29% of Australian adults say they're unlikely to take the COVID-19 vaccination. The research by Resolve Strategic found that 15% of adults surveyed said they were not at all likely, and 14% said they were not very likely to be vaccinated in the next few months. The World Health Organization now estimates some 8 million people have been killed by the COVID-19 coronavirus, with over 3.6 million confirmed fatalities and over 172 million people infected since the deadly disease first spread out of Wuhan, China. Scientists say what is now the world's largest iceberg could be around for several years. The massive block of ice, which is larger than the Spanish island of Majorca, has been named A76 and is some 170 kilometres long by 25 kilometres wide, covering an area of 4,320 square kilometres. The iceberg carved off West Antarctica's Rhone ice shelf on May the 13th and is now floating in the Weddell Sea. A76 is the latest in a series of massive icebergs to have broken off in the region, which is acutely vulnerable to climate change. It joins A23A, which at 3,880 square kilometres was the previous record holder and has remained in the same area since 1986. A new study claims the maximum possible age for humans could be between 120 and 150 years. The findings, reported in the journal Nature Communications, is based on a new method using blood tests to determine biological age, which they call the Dynamic Organism State Indicator. Fluctuations in a person's Dynamic Organism State Indicator score show their ability to recover from things like diseases. The authors found that Dynamic Organism State Indicator fluctuations increase with age due to an increase in recovery times. Based on those calculations, the researchers suggested the maximum human lifespan tops out at around 150 years of age. The Australian Health Practitioners Regulation Agency will soon be releasing revised regulatory principles to strengthen regulatory action on dodgy medical practitioners. Tim Mendham from Australian Skeptics says it's important the agency actually do something more than simply give shonky health practitioners a slap on the wrist.
Basically, this is the Australian Health Practitioner Regulation Agency, AHPRA, which looks after 15 different health practitioner boards. It works with them, implementing standards and accreditation schemes and things. Those boards cover everything from Chinese medicine, chiropractic, dental, medical, standard medical, nursing, occupational therapy, optometry, osteopathy, blah, blah, blah. So there's 15 of these different things, and basically those different boards are supposed to monitor and accredit and look after generally the practices of their members. So, chiropractic board looks after chiropractors, etc. AHPRA then works with these boards and makes sure that they're doing the right thing, hopefully, is the big point. It's looking at suggestions on how it operates at the moment. They've had a submission program in from the public and from sort of various groups, which is recently closed. Pretty high-level stuff, actually. It's not the day-to-day details of how it operates. It's more sort of its general approach and that sort of thing, which I know that a number of groups associated with the skeptics have put in submissions, etc.
That's what I was going to ask you about, because to me, how you can compare a medically trained general practitioner with someone doing acupuncture or a chiropractor is beyond me.
Yeah, I know, and that's part of the problem. And the next stage of this APRA review is actually looking at its dealings with these boards and how well the boards are actually reacting. And you're right. I mean, the medical board has, in the medical fraternity standard GP, have a process for receiving and dealing with complaints, and they have a pretty strict sort of judgment system on doctors who step over the line. And you always hear of a doctor doing something wrong, losing his accreditation as a doctor, being taken off the books, etc. Other boards are not so strong in looking after and monitoring their members. It's rare for the chiropractic board to stamp down on an individual chiropractor and say you cannot practice anymore. They might get a slap on the wrist. There was a famous case of a chiropractor who was cracking the back of an infant baby, like a few days old, and happily put that up on YouTube. And he got the admonition that you can no longer perform chiropractic on anyone under 12. Not to say you can't practice chiropractic. You just can't do it on kids, rather than say you're no longer a chiropractor, you're out of this business, baby, go. So that's part of the problem, that various of these boards receive on a pro rata basis more complaints than others. The question is, how well is APRA putting the hard word on these boards to actually implement what they're supposed to do? Some boards are tougher, some boards seem to be pretty slack.
It goes further than that too, because you're putting the shonks on the same level as medically trained people, and they're not on the same level. You can't regulate them the same way because it's water and oil, surely.
Yeah, I mean, sort of some of these boards are obviously dealing with areas of medicine, in quotes, which we would regard as sort of having a lot of problems, inherent problems. The Chinese Medicine Board and the Chiropractic Board are certainly dealing with areas that there's a lot of shonky practitioners, there's a lot of shonky practices, and a lot of very dodgy claims. Not to say they're all like that, but I mean, obviously there are some chiropractors who deal purely with lower back pain and that sort of stuff, which is fine. When they get into weird areas that we think the boards should be clamping down more on the associations which monitor their members. There's various chiropractic boards, chiropractic associations. One is the Chiropractic Association of Australia, and there's the Australian Chiropractic Association. There's various groups which have different attitudes towards how chiropractic should be undertaken. And the question is the National Board of Chiropractic monitoring all those and acting appropriately, and is APRA acting appropriately in overseeing those boards? It's complicated, but it actually should be a good system. Probably like most systems, it misses out occasionally in some areas, probably more than others.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.